Hi everyone, this is the last session before lunch, so I hope you all hang tight to the end. This is the panel manufacturer for heat pump manufacturers. So thank you for attending. One reminder is at the end of the session, if you want CEUs, we have a code for you to scan on your way out. My name is Jackie Albanese. I work for TRC. We're an engineering consulting firm, and we do a lot of work when I started implementing the programs, including Clean Heat Connect. We have a booth outside if you want to look at that, and we provide resources for distributors to pass along to their contractors to improve heat pump installs. We also run a program called Experience Clean Heat to try to get consumers noticing heat pumps in their everyday life, and we do have an event tonight. It's a social starting at 7:30 at Artisanal Brew Works, so I invite all of you to attend. Today we have 3 manufacturers represented here. We're going to do some quick intros. I have a few questions for them, and we are open to general audience participation questions. You can raise your hand, and we'll try to take them throughout and not at the end. All right, so we'll start with you first.
Yeah, good morning. So my name is Mike Brown. I'm with Carrier. I'm based out of the Syracuse, New York office. It's where most of our research and development centers are located. Currently, I'm the regulatory compliance manager. So I deal with the performance testing, codes and standards developments, and AHRI certifications, NEEP ratings, that type of thing for our products.
Good morning, Chuck Gaylord. I represent the Northeast for Samsung. I cover also New York City and Eastern Canada. My job title is an RTSM. I'm a Regional Technical Service Manager. So my perspective today representing Samsung will be mostly from a service side look at things.
Good morning, everybody. Ben Hiller with Daikin. I'm the Energy Efficiency Business Development Manager for the North Division, which means I get to work with the utilities on incentives for heat pumps. And I'm based out of Boston, and my office is in Texas, so I don't have to go very often. And looking forward to talking about heat pumps.
So we don't have any mics. Let us know in the back if you have any volume issues with any of us. Yeah,
I have volume.
okay. Let us know in the front if you have any volume issues. All right. So as heat pumps gain popularity and become mainstream, homeowners are looking for heat pumps that stand out, that are more efficient, provide better comfort. What new features or upgrades to heat pump efficiencies are coming to the market that you can kind of let us know about? Give us a sneak peek.
Well, I guess I would start with the DOE Cold Climate Heat Pump Challenge. That was something that Carrier participated in over the last several years. I think that has done a great job in promoting some new technologies to become more mainstream than they were in the past. So if you look at things like vapor injection and more advanced defrost algorithms, there's been a really good increase in the technology and probably the cost associated with that as well. So I think, yeah.
So in our systems, referring to Samsung and how we've gone to market with our systems, our low temp systems, we drive a little larger compressor, slower, to go ahead and deliver that low temperature heat for you, right? There's a couple different things you can do. You can take a small compressor and run it really fast to get that heat output, or you can take a little oversized compressor. So our amperages are generally a little lower than some of our competition, and we're not working that compressor as hard. On our systems now, we're down to minus 22, rated capacity down to minus 22, which gives us that about 75% heat output. We are working right now on our control package for the end user and the contractor, so making it easier for them to set up the parameters with with our handheld controls and things like that. So, we're switching now to the newer refrigerant, right? And so more and more better things coming down the road along with that.
Thanks. Yeah, I'd second Mike and Chuck and say we all have cold climate heat pumps. So you can come to any of the major manufacturers, and it's just a matter of what capacity do you need at what temperature, and help select the right product for you. That said, we are coming out with more features always. I'd highlight quality install is one we've come out recently, which can hopefully help prevent some service calls, some service trucks from having to roll. If you're able to remotely monitor a residential system, similar to what you guys might be familiar with on a building management system for a commercial job, bringing that same technology to residential jobs.
Thank you. Any audience questions on? Okay. Related to that, somewhat related, air to water heat pumps are becoming more popular. There's more products coming out in the market, and like air source heat pumps, air to air heat pumps, training, sizing, and design is very important. Do you have any kind of upcoming pending resources that installers could look up and to try to prepare themselves? And we'll start this time with Ben. Go this way.
I get to go again. I recommend hvaclearningcampus.com. Is a Daikin website, but the training is fairly manufacturer agnostic. Includes information about new refrigerants and also tax incentives. So again, that's hvaclearningcampus.com. Daikin additionally has Daikin University. We have both on-demand programs and instructor-led programs. If you can't find them through HVAC Learning Campus and you're subscribed to Daikin City, they're there as well in Daikin University.
So we offer SBA on SamsungHVAC.com, which is a Samsung Business Academy. So you can go in and you can do a self-led training, or you can sign up, do webinar trainings. Our partners across the Northeast offer locally here. We have a training center not too far from here that they offer a whole range of trainings. We have in our air to water, our AG or HT model hydro units, and you can access training, like I said, right online for those products.
Yep, and similarly, if you go to carrier.hvacpartners.com or Carrier University, there's a bunch of training materials that have been made available. Carrier is going to be introducing a new product to the air to water market here in the next month. So if you stay tuned at the International Builder Show, there will be a new press release and some new products coming out there. So after that, you will find some of the information on carrierhvacpartners.com.
Where do you all see the air to water market in the next year and the next 5 years?
So I think in the next 5 years, we're expecting a large market of the electric resistance, hot water heater storage market to be transferring over to the heat pump side of things. So we're anticipating further development of that market and look forward to introducing some new products.
Yeah, it's nothing but going to grow. I have right now actively in the state of Maine, 2 or 3 job sites. I have a partner up in Eastern Canada that is putting air to water systems in, 3 or 4 of them going right now. And I just suspect it's going to, a lot of these jobs have to engineer around thermal mass. So they're trying to heat up that water, have that for a reserve.
Mm-hmm.
But I think the market's just going to increase on that side.
Are those retrofits?
They are not. So
I have a very long answer. I'm really excited for air to water heat pumps. So I can probably talk for the entire rest of the hour just about air to water heat pumps. I'll try not to do that. For anybody who hasn't heard of air to water heat pump before, it's the same outdoor unit you're familiar with that absorbs the heat from the air and releases it inside to water. So instead of releasing the heat to air, which is air to air, you release it to water. So it's air to water. And we finally have hot enough water to offer you a boiler replacement, which is huge for the Northeast. All the existing hydronic radiant systems we have, we can replace the boiler and feed 160 Fahrenheit water into systems that may have said they were designed for 180, but were probably oversized. If you needed to add more radiators, you could, but what we're finding is you don't. You simply replace the boiler with the air to water heat pump and use your existing, you can use cast iron radiators, baseboard radiators, fin and tube radiators, and then you can do your domestic hot water as well. So the same system will serve an indirect domestic hot water tank. And if you're in a mechanical room or in a basement, a residential basement, you'll probably see a boiler and a separate hot water heater. And they may fail at different times or be on different schedules of being replaced, but they're both heating water. So with one air to water heat pump, you can actually do both functions. So there'd be no need to have two separate systems there anymore. And you can run it in reverse for air conditioning. So it's a tri-mode system. You choose how many of the three modes you'd like to use. The indoor units for cooling just need a drain pan, because you can imagine if you tried to put chilled water through a radiator, you'd get condensation in the summer. So wherever you're directing the chilled water in the summer, just make sure it has a drain pan, a condensate drain. And then you have yourself a tri-mode system. So my job is working with the utilities on incentives. And if you guys are familiar with some incentive programs, you'll probably see completely different incentives if it's a water heater or a boiler or a heat pump. So one of my jobs is to try to incentivize how can we help cover the cost of this tri-mode system if it's doing up to 3 functions. And can I please have 3 rebates at once? That would be an easy answer. Now this product I'm talking about is called Altherma from Daikin. And you can Google it now and it'll take you to the European webpage. And we're hoping to launch it this fall in North America, particularly West Coast and East Coast, and especially the Northeast, where we have so much hydronic heating with an opportunity to replace boilers and water heaters. So it's tried and tested for 10 years in Europe. We're also looking to add production in the United States. So it soon could be made in the USA, in Texas, where my office is. And I'm very excited for that product.
Have you seen any installation issues? Sorry.
Installation issues, it's going to be training because it's hydronic system. So a lot of our technicians who are familiar with refrigerants, this machine, the refrigerant stays in the outdoor unit. And it is R32, one of the new A2L refrigerants.
What's the capacities?
5-ton nominal and 4-ton nominal. And in Europe, you can put 6 of them together. So you could actually string a few together to displace the load of a commercial boiler. And that might be an easier sell if a building owner isn't ready to get rid of their commercial boiler, but could displace some of their load and thereby some of their greenhouse gas emissions with an Altherma unit.
What kind of COPs are you seeing with taking that water all the way to 160 degrees?
Depends on how cold it is outside. Capacity first, if you're curious, it's 100% capacity maintenance at 5 Fahrenheit. COPs at that temperature, around 2, maybe a little lower than 2, always more than 1. And I like to say fossil fuel combustion is always less than 1. And I'm the energy efficiency guy. So when anybody asks me energy efficiency, I get to say the heat pump is more efficient. And then it's a matter of cost. I'm working with one utility that's targeting a seasonal COP of 3.0 as a target for cost parity with natural gas. So if we can get around that, which we are getting in Europe, so we're hopeful that it translates over here, we hope to get cost parity with natural gas. And please don't change the rates on me while we're trying to do that.
Okay. Do you, either of you also offer any high temperature options for air to water, or do you have any potentially coming to market?
Unfortunately, I wish I could talk more about the product in mind right now, but I'm gonna have to direct folks to wait until the end of this month after the IBS show for some more information on that one.
Yeah, we have a HT, our HT model
Mm-hmm.
is 100 rated for 176 degree water. They said in the state of Maine right now, they're doing a system where we're actively heating a buffer tank. Then they'll switch over to the storage. Their goal is to have 176 temperature water, and that is all being heated at night on the night rate. And then in the day, we've got that thermal storage to go ahead and heat the house during the day. So.
I just want to add that's a really great point on thermal storage. That way you could heat the water at night when it's most advantageous to the grid and hopefully your rate, and then store it.
So a portion of portion of heating issues and installations happen during emergency outage situations. It's always easier to pick a like for like replacement. So if they have a furnace, they'll replace it with the same size furnace. Do you have any recommendations for distributors, contractors, or how to best heat the space temporarily while they potentially size and design for a heat pump installation instead?
Don't,
Any one of you could answer this. It's a tough one.
yeah, when you guys want to pick it up.
I mean, it's going to be, it's not one thing does all, you know, it's going to be, you know, are we putting some temporary resistance heaters in, or, I mean, it comes down really to the contractor of what he's prepared to do to get that sale. You know, I've dealt in the past, I've dealt with contractors not too far from here. They have a spare outdoor unit. Their customer's unit goes down, boom, they yank it out and put a new one in there, or a used one ready to go. So they don't have any downtime. So it's going to be, you know, maybe bringing in a 92 furnace and set it, you know, a high, you know, 90 plus furnace, setting it up and getting some heat to that structure while we do things. But really nowadays, like a heat load calculation, I mean, that can be done at the kitchen table in 20 minutes to an hour. So that part of it, the design and the financing and getting that part of it is probably going to take longer than, you know, getting to the point where we picked out the equipment. But so.
Go ahead.
Yeah, the one thing I'm gonna say, you know, here in New York in the winter, if you're trying to change a boiler system out to a air source heat pump, not necessarily the easiest task. Probably, in my personal opinion, dual fuel options are one of the more beneficial things out there. For your air source heat pump with a furnace, in the event you have a outage, you know, you have that backup heat to go to. So I think just having the flexibility in mind for you know, backup space heating, you know, maybe you can get away with some electric space heat if it's not too cold outside. But I guess keeping in mind for the area what the common setups are, and then having folks keep the solutions in stock to replace those will make the replacement as quick as possible.
I totally agree, and would just say I think you're highlighting that it's a really difficult situation. You're most likely to replace like for like when your customer is without heat. They're not in the situation where they can get multiple quotes and consider new technologies, even dual fuel, someone might say. And that's a good point that could be a quick solution there. I would just say it comes back to maybe if you have a service agreement and you're aware ahead of time that it's coming and you're doing annual checkups with this customer, you might have a plan ahead of time. That might be a better way to do it. And you would be completely fair to say, yeah, but the customer didn't buy the service contract. And I'm trying to get them written into incentive programs wherever possible, so that we all as an industry can have a better opportunity to be prepared for when that replacement needs to happen.
Where do you all see the refrigerant market going in the next 5-10 years? I know all these new refrigerants are coming up. There's the reclaim market. There's a lot of regulations. Where do you see it going?
I would say that's a complex discussion. There's things happening at the state level here in New York. There's things at the federal level as well as globally. Here in New York, there's some activity on banning PFAS and HFCs in the near future here. Generally, I would say I see the industry going towards, we're in the A2L transition period right now. I would say research on A3s is ramping up, and the industry eventually will be heading towards low or natural type refrigerants. I think that's probably in the 10-year side of things, but yeah, definitely in the midst of transition here.
How would you define a natural
CO2 would be an example. Propane, just anything that's not a HFC type refrigerant.
Yeah, I agree with them 100%. It's most likely going to be driven by government, right? Once we've picked a refrigerant, we'd still be with R22 if it wasn't for somebody told us that we had to change and get rid of the R22. That being said, we're going personally with the Hylex. We have a Hylex unit that is a universal replacement unitary heat pump for air conditioning or the heat pump application. That's going to be the 454B refrigerant, and then everything else in our product line is R32. But I got to agree with them. Eventually, maybe 10 years down the road, we'll be going to those CO2s and the propane and that type of in that direction. So,
one thing I'll add there, if I could, the R32 product, that is something that is in the natural refrigerants are more prevalent in the European market today for lower charge applications where you have your system outside. I think where we're seeing things going is in Europe, they're now looking at larger charge amounts and bringing those units, bring the charge inside the structure. We're probably going to be looking at something similar here in the U.S. as the industry develops and research gets more robust on that.
I could talk about this one for too long as well. If you're interested in refrigerants, backing up to the first transition from R22, we transitioned away from that because of the ozone depletion potential. And that was a worldwide success. Everybody agreed to phase out R22 and similar chemicals because of their ozone depletion potential. We could have had a hole in the ozone, which prevents us from the UV radiation from the sun would have been frying us at this point if we had an ozone hole. So we agreed on that one. What we didn't agree about was the next one, which was global warming potential. And it has taken the United States in particular a very long time to catch up with the rest of the world in phasing down the refrigerants with global warming potential. And at this point in the course of global warming, there's a pie chart from the EPA that shows how much each gas in the atmosphere is contributing to global warming. And refrigerants and similar chemicals are an extremely tiny slice. And the biggest slice is carbon dioxide. And another really big slice is methane, which is natural gas. So from my perspective, and hopefully our all's perspective in building science and what can we do for buildings, the question is, how are you going to heat the building? Is it going to be combustion? Or is it going to be some type of heat pump that's recirculating the refrigerant and not reliant on a continuous supply of pipes underground, all the infrastructure to get the natural gas all the way to you, and then burn it. Pie chart from the EPA wise, I'm ready to call the amount of global warming potential from the refrigerant minuscule compared to the amount of global warming from our alternative heat sources, which are fuels. So from that perspective, we just did a huge amount of work to transition to lower global warming potential refrigerants. Now we're hearing in New York, we got to go to 0 or very under 10 global warming potential. They call it ultra low global warming potential. What's happening is it's making it difficult for a consumer, someone responsible for spending the money, to choose an alternative to fuel. So yes, absolutely, in the next 10 years, we're going to see them go even lower. But from our perspective today, we just had a tremendous success getting it lower than it was. R410A had a global warming potential, the metric they created for it, of around 2,000, and now we're under 700. Everybody's under 700. The chemistry of it is really interesting. R410A, we started with R32 and switched to R410A, which is a blend of 50% R32 and 50% R125, which is a fire suppressant to pass a flammability test. Outside the United States, there are over 200 million installations already of pure R32 and similar refrigerants that are the A2L flammability rating, which now finally are allowed in the United States. In the same pipes next to it with natural gas and propane, if you're concerned about flammable pipes in your building. So I'm not concerned about the flammability of A2Ls, given that. And finally, we have them in the United States. The question is, will we go lower? We brought up natural refrigerants. Can you use CO2 as a refrigerant? Absolutely. It's not great for every application. So in regulating it and saying, try to make everything CO2 or propane, another classified natural refrigerant, it's not good for every application. And therefore, it's not helping us as a country decarbonize faster. So I've been on the regulation side, I've been on the manufacturer side, I feel like I'm in the middle. It does take communication at conferences like this between everyone to come up with how we can best proceed.
Can you give an example of an application that would not be appropriate for that?
Small ones. So large chillers were the easiest. Large compressors which spin slowly and operate at low pressure have great solutions available already with ultra-low GWP. As you get to smaller and smaller units that are high pressure and the compressor spins fast, those alternatives are flammable. So we're at mildly flammable right now. If you get to propane, that would be a class 3 flammable. And we'd be approaching where we were in 1922, I'm going to say, when we invented Freon in the first place, because the refrigerants, like ammonia, which is still used today too, were either flammable or toxic and dangerous, is why R12 and R11 were invented in the first place. We're seeing this in a lot of industries where the push for lowering metrics of global warming potential is leading to trade-offs. So in our case, the trade-off here is flammability. Also, I do want to answer the question even better to say that CO2 needs a high lift, meaning that you really need a large load attached to it. We're seeing with the CO2 water heaters available right now, if they're at part load, they might just be switching to electric heat. which really is fine with me from a decarbonization perspective. But saying we're going to give you a CO2 heat pump, which operates as an electric heater a bunch of the time, then becomes, again, a question of operating cost, where you could have gotten the same system. This is an actual example. We have a product called MegaQ from Japan, and it's a cascading heat pump. So it's a heat pump for your heat pump to get the water hot enough, and uses 2 different refrigerants and can arguably save you operating cost compared to a CO2 system. But you might not like the refrigerants because they're the old style refrigerants, and that's how the machine operates the best. It's really fun for me. I've gotten to speak with Japan, or engineers in Japan, a little bit. And North America is a very unique market. And they kind of say, well, how come North America? What do you mean? This is what makes sense. And we say, well, yes, but the regulations don't allow it. And then you have to translate it between English and Japanese. So it's a very interesting job.
Something that's always top of mind for building owners, homeowners, is system price. Where do you see that headed in the near term, and then potentially in the future with various product lines?
Well,
And first cost and operating costs.
I would say, you can't argue with the fact that heat pump systems are going to be more complicated than your typical AC system. It's going to be more complicated than a natural gas furnace. There's always going to be a bit of a cost parity there. One of the things to pay attention to is the rebate opportunities. I think, depending on where you live, you might have up to $10,000 in rebates that are available to you. That helps, address some of the cost concern on the initial investment price there. So it's not necessarily just the initial costs when you're looking at the rebates.
Yeah, unfortunately, due to the transition to the newer refrigerants, we under certain codes and requirements, we have to have added components to the systems now. For sometimes we'll have to have a refrigerant detector, so that's going to add to that system cost. So in the near term, yes, things are going to go up. But like what we mentioned before, the rebates, state programs, things like that, to help hopefully to offset some of that. And then yes, in the maintenance, we're trying to take and always evolve these systems to be higher and higher output, higher efficiencies. Anything that's a higher efficient operating unit. Doesn't matter what type of product it is, it takes a certain level of maintenance, certain level of skill to keep that unit running at those efficiencies. So that is always going to be a higher than that mid-efficient fossil fuel burning product that we have in our houses. And in the end of the day, it's going to be more to keep that unit running at those higher efficiencies than what we have out there, and then those fossil fuel systems. So.
Agree, and I would add that manufacturers have a good, better, best marketing strategy. So we try to be conscious of costs where the customer would like a lower cost product, and we try to be conscious of where the customer would like a higher efficiency product, which is where they're going to save operating expense. And it is typically, called the good, better, best approach. In the Northeast, where we are, we're trying to get the best. We want the cold climate heat pumps we were just talking about. We have them. We all have them. You can have them too, but they're expensive. And that's why incentives are driving the market, I would say. And we really hope there are continued incentives and continuing to work on structures of how we can get the best I'm really trying hard not to call it a luxury product. All it is the product that works in the Northeast, but it's the highest tier product from all the manufacturers. How do we get that into customers' hands?
I know what I've heard is a lot of folks who transition to heat pumps, sometimes they are not fully educated on the operations of it, and that usually leads to some disappointment, or they're not fully aware of the maintenance involved, and then it doesn't operate correctly because they're not maintaining it. Do you have any resources or any tips for contractors to prepare the homeowner, the building owner, of what to expect and how it might be different from the traditional fossil fuel or air conditioning that they're used to?
Yeah, you know, there's no argument that a heat pump system is probably going to put out, in some cases, slightly lower air temperature than your fossil fuel furnace. So if you're changing over to a heat pump for the first time, there's going to be some intricacies in the operation, especially here in New York. So as you mentioned, just being aware of how the systems differ is first and foremost. So again, I would probably direct folks to our training material on Carrier HVAC Partners, just to prepare themselves on having that conversation with the customer on how it's going to be different, and keep that first and foremost in your mind.
Yeah, I would. I recommend all the contractors work directly with that end user to walk them right through the operation of that unit, what to expect. Why doesn't the fan turn on when I turn the heat on? What's going on for that first 15, 20 minutes? Why isn't the heat automatically starting to come out already? We're going to pre-warm that coil up before that heat starts discharging off that indoor coil. So things like that really need to be stressed to that end user and almost hold their hand and walk them through it. But we also have on our website Samsung HVAC things for the homeowner to help them with that transition from that fossil fuel to that new mini splitter or system that they're going to put in.
Agree. I can't add much to that. I think with something new, there's always going to be questions about it, and just as nice as the contractor can be explaining the system they've installed, is the best bet.
Great. Yeah, my personal examples are because the programs I work on, a lot of folks forget to change the filter, clean the filters, and so they see degradation in the heat capacity that they're getting from that. Do you have any final thoughts? We've run through my questions. You have audience questions if you have any questions. I can start with Ben. I'm sure he'll have some thoughts.
Does somebody else have thoughts? I feel like I got to talk a lot. I'm happy.
No, like I said, any questions for issues, challenges that you guys face, things you want more information on. I don't know what's on your mind.
Addressing small rooms with pumps, techniques, any upcoming strategies, or thinking some small bedrooms might only need 6,000 or even less use capacity. So is there any product development you see that can address those smaller needs, or even some creatively placed jumper ducts or something like that?
Well, I would say if you have multiple smaller rooms, probably one of the more ideal solutions is looking at a multi-zone system. You can pair a smaller 3-ton system with several 6K indoor units. So that's always ideal. And you can also look at zoning systems. If you have a mini split paired with a ducted unit, and that'll allow you to kind of custom tailor your particular installation depending on the structure.
Yeah, I've seen that a lot where unfortunately contractors like those 9,000s and they'll throw those 9,000s and into a small bedroom, and if you do a load calculation, it's a very big bedroom, requires a 9,000 BTU unit. And, if you put it on a multi-head system, then you've got issues with overshooting temperatures and, in our heating, in our heat pumps, right? We keep those expansion valves open. We allow that hot gas to flow to those indoor units, and that can always cause problems when you have systems that are designed with indoor units that have unique running characteristics. You put that big unit down cellar to take care of that family room, and that's running majority of the time. Those other units upstairs in that bedroom now are just overshooting those bedrooms. So those are always a workaround trying to get that settled. And then definitely it's a worst case scenario when those indoors bedroom units are oversized to a 9. And, unfortunately, the industry doesn't, some manufacturers on the commercial end do have 4,000s BTU indoor units, but in the residential product line, I don't think anybody has those smaller units. I just did a system for my house last winter. I could have definitely got away with a 4,000 BTU unit, and the 6s are definitely oversized, and I can see them just bang on, bang off all the time. So it's a tough thing to, like you mentioned, maybe a ductwork, if you could do 2 bedrooms off a ducted system or ducted indoor unit. So
I have a 2-part answer, and you just hit the nail on the head with you see it bang on, bang off. I just want to say that's what you were going to have anyway with an air conditioner. And I think we're all familiar with window units. They certainly bang on and bang off. You can hear them. So all of us are offering variable speed equipment, which reduces that, basically like a dimmer switch for your light running at the correct speed longer, which is better for humidity control. And I probably shouldn't even have brought up humidity control, because now you're going to ask about humidity. But my answer goes back to your alternative, which everyone's had for decades, is the window unit that bangs on and bangs off. So how can you now say it's a barrier to heat pump adoption where we're offering variable speed compressors, which are obviously better than what you had? So my 2-part answer is, if it's new construction, completely agree. You can do a multi-split with multiple smaller units, is an excellent design. If you say, well, it's a retrofit, I can't do that, I'm going to say, what's your infiltration rate? What's your envelope look like? How much renovation are you doing? Are you trying to turn it into passive house standard? Is there an energy recovery ventilator? Is there a heat recovery ventilator? What are you doing for ventilation? Is it just the air leaking? Is that where you're getting the ventilation from? If so, then you're not going to have humidity problems due to how our unit is sized. The humidity issues are because your humid air in the summer is leaking into your house. That's literally how you're getting ventilation. So I would say for a retrofit, I'm not actually that concerned about the 6,000 or the 9,000 BTUH unit that you were going to get anyway as an air conditioner. And if you're doing a good new design, then we have options for that too.
I just have a question. I'm not sure with each individual manufacturer if you guys use branch boxes or not with your applications, but if you do, I'd love to hear your take on the use of branch boxes versus splitting a system up into multiple outdoor units and limiting the use of a branch box.
It's free for all.
So, we've made the choice to not utilize on our mini splits. We're all home run. On our mini splits, we do make a single phase eco unit that does utilize a mini split, and I've seen them, both ways. Obviously there's some jobs that the home run unit is ideal for, and then hey, I've got I got the spot to put that that branch box, you can call it, or MCU we refer them to, in that centralized location, and then feed off of that. So I don't think one unit is one unit doesn't would never fit every structure. So it gives you the flexibility.
Yeah, for the carrier systems, my previous experience is with the VRF. In those heat recovery systems, we have the branch boxes. For some of the smaller residential units, we don't use them. So it's not really like a one size fits all approach.
I agree, you can do both. I've seen incentive programs recently try to favor one-to-one only, which is an interesting choice. I really think every house, every multifamily building, apartment complex is, should be looked at individually. And it's, I think, unfortunate when incentive programs force it, for example, into no, you shall only use one-to-one mini splits. What if it would have been perfect for a cold climate 4-port multi-split with one large outdoor unit? How are you going to convince the homeowner that what they really want is 4 little outdoor units? Where do they put them? Could be just a real life example.
Any other questions?
I was wondering if anyone's ever had experience putting outside the dressing unit, like in a very large attic. Do they have to go outdoors?
It's called a penthouse on a commercial job. And then you can even condition the penthouse to make sure the conditions are acceptable for the outdoor unit in there. So that is a technique for cold climate system. When it's extremely cold outside, you can actually condition the air that outdoor unit is seeing. I haven't seen it on a house.
Yeah, we do that all the time in the commercial, but for residential, I know somebody that has a garage house, you can call it. He's a bachelor. He built a massive garage. Part of that garage is his house. His indoor units are in the garage part of so he's tempering that to maybe like 50 degrees, and then heating his part he lives in. He's a refrigeration mechanic by trade for 30 years, so he's tinkering with these units, doing things to them himself, and has quite a mechanical system there to heat his place. So.
Yeah, I'd say my biggest concern with just sticking a unit into a attic would be, condensate disposal if you're running the unit, and heating mode in the wintertime, and then obviously overheating in the summer. So probably wouldn't just want to take the unit and just put it in an attic without some extra steps in there.
Any other questions? We have 11 minutes before lunch.
We're not stopping you from getting to lunch any faster.
Do you?
ERV, ventilation is the new thing. After COVID and everything, everybody needs to start paying a lot more attention to ventilation, especially with type of houses. And I'm very curious about ERVs or HRVs being paired with heat pumps, or at least if the heat pumps can incorporate some ventilation in them. Are any of you aware of up and coming techniques or models with that?
I would just say tried and true techniques. You need someone who's familiar with them, but they're tried and true techniques to do with ventilation. A lot of our systems do not include ventilation, and it's still called heating, ventilation, air conditioning. So the ventilation is in there somewhere, and you're either doing it on purpose or letting your room leak air.
So in our commercial product, we have 100% outdoor units that will deliver neutral air down to 14 degrees, and then you have to supplement that temperature to our unit. But mostly in our commercial product do we have solutions for that.
Is there a reason why you don't have them in residential situations?
I really couldn't answer that. It probably demand. Does HQ see a demand for that product? They might have that product over in Europe or in Asia and just don't see the demand to get it qualified to bring it into the North American market.
I would love to second that response. Up and coming demand in the United States for efficient building as opposed to inexpensive building is what we're up against. As manufacturers, we've tried to launch various products in North America and given up, and then come back and try it again. There's a very vocal majority working to keep buildings as efficient as they currently are, which is not very.
Do you have any products that you have in Europe or in Asia that you really want to be in North America, but it just hasn't made it?
Products that we want to make it here?
Yes, yeah.
My favorite, Altherma. If you Google Altherma, my tri-mode air to water heat pump.
I would say probably the VRF hot water heaters. Those are over in Europe currently, and I'm hoping they'll make an appearance in the North American market in the near future.
And we have hybrid hot water heaters that are coming into the United States and should be introduced at the end of this year or 2026. So.
Anything else? Last call, and then I might break us early. That's okay with you all. Do you have any final thoughts that you want to say to the group?
This is my first time at this conference, and anybody to do with building performance and contracting, I'm please come ask me any questions you'd like. I think it's so important for us all to talk together. We're all manufacturers here, and I think we all want to help. So please, and thank you for all the work you're doing.
Yep. Say likewise. If you see me walking around, please stop me, ask me questions. I like chat with everyone.
Same thing. I'm available and or willing to talk.
I have one last shameless plug for the event tonight at 7:30 at Artisanal Brew Works. If all of you want to come, there's trivia, prizes, swag, all those things, and food. So let's give a hand to our panel.